Jai Jayendra, Namaste, welcome to my channel. Today we are going to solve the 30th and the last question of the array topic of the problem solving series. So the difficulty level for this question is hard, actually very hard. And this question has been asked in Google, Facebook, Amazon. And so let's begin. Count reverse pair. So we need to count the reverse pairs. We are given this array, and to understand what is reverse pair, here I have written it so that we can remember while solving the problem what is reverse pair. So a pair is a reverse pair when, say, pair ij is a reverse pair when I and j will obviously belongs to will be greater than 0 and less than n is the size of the array, and the ith position array I is greater than twice of array of j. Here in this example, if you see, okay, here if I is 1 and j is 3, so is 1 greater than 2 into 3? No, it is not. But if I is 3 and j is 1, so a of I is actually greater than 2 into array a of j, right? That means 3 is greater than 2 into 1, right? So we need to return those number of reverse pairs, count them, and need to return the count of those reverse pairs. So here in this case, 3 and 1 is one of the pair, 3 comma 1, and this 3 and this 1 is also one of the pair, 3 comma 1. 2 comma 1 is is a reverse pair or not? No, it's not, because 2 is not greater than 1 into 2, it's equal. So here we have two reverse pairs. So in this example we can see that 4 comma 1 is a pair, 3 comma 1 is a pair, and 5 comma 1 is also a pair, right? 2 comma 1, 3 not 2 comma 1, 2 comma 1 is not a pair, 3 comma 1, 4 comma 1, 3 comma 1, and 5 comma 1. These are three reverse pairs. So we need to return 3. So how do we solve this? Do you find this question to be difficult? It's very simple, right? If we traverse the array, we have we will have double loop. So I will be the outer loop, will rerun I to j and then I to n, and then we will rerun j, where j will be actually I plus 1 to n, and then we will compare whether this I is actually greater than array of j or not, and we have a count variable, and every time we see it is there, then we'll increment count and we'll return count. Isn't it simple? Let's code it then. So why we are saying it is a hard problem? Int count equal to 0, and then for I equal to 0 to n, and j equal to I plus 1 to n, of course n minus 1 I mean. So if array of I is greater than 2 into array of j, then we increment count plus plus and we return count. It's simple. What is the time complexity? Time complexity is order of n square. Space complexity is order of 1. It's done, but it's not an optimal solution, of course. So we have to we can give a better solution. N square is not the optimal solution. So how we can improve it? We are doing this, but is there any better approach? Yes, this is a brute force approach, and there is an optimal approach. So let me give some intuition about the optimal approach. So here we will actually use a merge sort algorithm to solve this problem. What is merge sort algorithm? So merge sort is a sorting algorithm which sorts the array in order of n log n. What it does, it divides the array into two halves. It repeatedly divides it. It's a recursive algorithm, and when it is at the bottom, it actually compares the value and see whether it is the lower index element is less than the uh, greater index element or not. If it is not, then it swaps them. And then once it is done, it merges all of those elements, and in that merge process, it's a divide and conquer algorithm. So once it's done, so whatever we get, it is a sorted array. So can that algorithm be used to solve this problem? Here we don't need to sort this array. We just need to get the count of the reverse pairs. So how that algorithm will help us to solve the count of reverse pairs? So let's understand it. I need to rub the board and we'll understand that algorithm. Let's look at this example. Okay, here we have got an array 40, 25, 19, 12, 9, 6, 2, and we need to return the reverse pairs. So we apply the merge sort algorithm over here. Okay, merge sort. So what we do, we divide this into two halves. Okay, so 3, 4, 5, 6, 7. 7 elements are there. So 4 elements here, 3 elements here. Okay, so 40, 25, 19, 12 is here, and here it's 962. We could have done 40, 25, 19 and 12, 962. Anyway, no issue. So again we have divided it into halves. Again we have divided it into two halves. So here we have divided it 40, 25 now. So it's divided and they are single elements. Okay, this will be done recursively. We have discussed in the previous question one example of recursion. So here when we have 40 and 25, we compare whether 40 is 40 less than 25 or not. It's not. Then what do? We reverse it. We do 25 and 40. We reverse. We change this index and then we return this 25 40 over here. So this becomes 25 40. Okay. And here it will become 12 19. So when we have for 25 40 12 19, these two are sorted arrays, right? So when we do this change, when we get two sorted arrays, we will have another function which would merge these two sorted arrays into one array. So it would compare this with this. Since this is smaller, so 12 will replace 25. So if this is smaller, so then this. If 12 is smaller than 25, 12 will obviously be smaller than 40 because 25 is smaller than 40. Right? So then we actually check with 19. 19 is also smaller than 25. So 12, 19 comes after 25, 40. So you need to study merge sort algorithm. I hope you know the merge sort algorithm. I am explaining it over here. So this problem will be solved with a modified version of merge sort algorithms. First I am just explaining this merge sort algorithm. So this will become actually 12, 19, 25, 40. And similarly this will actually become 2, 6, 9. Okay. And then this will be merged the way we merge these two. Again this should be merged. So we will have a merge sort function which keeps on dividing it into two halves. When it is divided, it changes it, and then will be a merge algorithm, merge function that merges all the merge sorted things. So in this way we merge sort this array in order of n log n. Now we will modify this to solve our problem. What do we need? We need to count the number of reverse pairs. So see here, for when we have 40 and 25, okay, so here we have changed it to 25 40, but if we check, since this is I and this is j, ith index has to be lesser than j. So is 40 greater than 25 into 2? No, it's not. So this 40 and 25 can't be a reverse pair. So we give it over here. Similarly, 19 and 12 cannot be a reverse pair because 19 is not greater than 12 into 2. Now we have 25, 40, 12, 19. Before merging them again, here we have merged this into 25, 40 and we have returned it, right? So before merging this 25, 40, 12, 19 into this, we'll have another function or check where we'll count the reverse pair here. How do we count this? We have two arrays. Okay, this way we are considering as two arrays. Consider these two as sorted arrays. So now we check whether this 25 is 25 greater than 2 into 12. Yes, it is. So we have a pair, reverse pair, 25, 12. Okay. So 25, 12 is one pair. So we have got one reverse pair here. Okay, 25, 12. So if 25 is greater than 2 into 12, so can we say 40 will also be greater than 2 into 12? The way we shorted this. Similarly, this is greater, right? 40 is obviously greater than 25. So it must be greater than 2 into 12 also, right? So for 40 also this will work. Just a thing. But before coming to 40, first figure out how many numbers can we have pair with 25. 25, 12 was a pair, then we move this to this one. So 19. 25 is not greater than 19 into 2, it's 13. So this can't be a pair. So here, when we come over here, we have only one pair, 25, 2. When we come to 40, then we don't need to start it from 12. We will be starting it from 19 because we know 12 will be a pair with 40, right? So that is the analogy, okay? So now 40 is greater than 19 into 2. So we have got another pair, that is 40 and 19, okay, while we are sorting it. So we have got another pair. Now we have two pairs, okay. So here we had two pairs, we have got this value now. Similarly, when we were here, we were finding the pairs, there were no pairs with this 9,6. 9,6 is not a pair, we changed it to 6,9. And then this is 2 single element, 6,9 here, 6,2 is a pair and 9,2 is also a pair. So 6,2, 9,2, we have got two more pairs, okay, plus two more pairs here in this 269. Okay, here two pairs were there and here two pairs are there. Okay, total we have 4 pairs till now. Okay, now in this one we will be finding this in the same way, we will find the pair. Okay, so we are in 12. Okay, now we already have these elements. We can't find pair with among these two arrays, right? We have two, we can't find pair within one array. We are going to find pairs with when the arrays are different. Okay, we have two different arrays now. So now 12 and 2. Okay, so 12,2 is a pair. Okay, 12,6 is not a pair. We remain in 6 and we have a count 1. Okay, so recursively we'll maintain that count and that will keep on adding it. When I'll solve the problem, when I'll do the code walkthrough, then I'll explain how we will code it. Okay, first let's understand the approach. So here when this doesn't work for 12, we move this 19 and we don't go to 2, it will start from 6 only. So 19 works here. So for 19 it works. So 6 into 2 is less than 19. So for 19 it worked. So again we move this one. So 9 into 2, 18. This is also works for 19 also. So for 12 there was one pair. For 19 all of them are pairs. Okay. So if for 19 all of these are pairs, that means for 25 and 40 also all of this will be a pair, because 25 and 40 is greater than 19. That means here we will have plus 3 plus 3. That means total of 10. So 10 number of pairs, so 4 plus 10 is equal to 14. So we will have total 14 reverse pairs in this example. We also have what are the pairs. If that is given, we can return that as well. But we need to find the count of the reverse pairs. So in this way, when we are doing a merge sort, when we do a merge sort of this array, we will have another function where we will use that analogy and we will have that code that we have written, right? How to count the reverse pair in the beginning. We'll use that and then we will solve it. So in this way we can solve this problem. What is the algorithm? What is the time complexity of merge sort? Simple merge sort, and then this thing won't be a big difference. It would be order of n log n. Okay, and space complexity. We are not taking extra, so space complexity, since it's a recursive function, it will be extra stack space. So since I have not coded this, I'll code it in the code walkthrough section itself. So if you can try to code it yourself, otherwise you can come to my code walkthrough section. The link to the question has been given in the description. Here's the code walkthrough of the 38th question, reverse pairs. So we have discussed this example, so let's look at the code. So here we are to implement this reverse pair function, we are given the vector of int nums, and we have got the low and the high value as 0 and the size of the nums vector, and we are passing this parameters in the merge sort function. So here in this merge sort function we have implemented merge sort. I would suggest you to look at the merge sort algorithm. So here we have done what we have discussed before. We have implemented the merge sort, but also we have this count plus variable where we are counting the number of reverse pairs. So as I have shown during the explanations and the solution to that problem statement, that we are getting the count plus value just before implementing the merge function. So with this merge sort recursive function, we are dividing the array into two halves, left half and the right half, until it becomes a single unit value. We will be dividing it, and then we will be counting the number of reverse pairs, and then we will be implementing the merge function where we will add up both the halves. So here in this merge function, you can see we have just implemented how it is implemented in the merge sorting algorithm. So this is same code, but the main thing is this count pair function. So where we pass the array low, mid value and the high value. So this count pair actually contains both the arrays. So we will compare both the values. So from low to mid there will be one array, and from mid plus 1 to high there will be the other array, or the other set of numbers, and we'll be comparing the both the set of numbers. So here we are comparing from till right is less than equal to high, we'll compare I equal to low to I less than equal to mid. So you can see here we have made it as a double. We have converted into double because if we know the size of int type is there's some number like max number. So if we see that that max number is in our set, then 2 into that max number of integer value, that would cross the value that integer data type can store. That's why we have converted it into double. So here we are comparing whether this array of I is greater than 2 into the array of right or not. So if it is there, so we are incrementing the right plus value, and we will get the count value by this right minus mid plus 1. So we are not again going back to the right value. So when we are incrementing this I to from low to the next value, so obviously if the mid plus 1 value, if the I equal to the next value, if I equal to low is greater than the 2 into double of area of I, then the next value would obviously be greater. The logic that I have shown with the example, the same thing I am implementing here. And yeah, so I think you'll understand this code when you'll see this logic and run it yourself, do the try run. So let's run this directly, or rather submit it directly. So the main thing is just the count pair function, and if you see the merge sort algorithm, you'll be able to understand it. So here the solution has been accepted. So this count pair is the code that I have explained with the example. Here is its code walkthrough, and yeah, so this is the end of the array topic. Next I'll be starting with the binary search topic in my 31st video. Thank you. Jai Jendra.